Firewall deployment considerations. Learning objectives and key concepts. The learning objective for this module will be describe the fundamental functions performed by firewalls, common firewall technologies, and the elements of firewall implementation and configuration. Key concepts will be firewall deployment security strategies, AAA, or known as authentication, authorization, and accounting, reverse proxy and port forwarding, monitoring and logging, and firewall logs and alerts. Some common security strategies for firewall deployments. The concept of security through obscurity, least privilege, simplicity, defense in depth, diversity of defense, choke point, weakest link, fail-safe, forced universal participation. The concept of security through obscurity is the idea of gaining protection by using abnormal configurations. Common and mistaken examples of obscurity-based security is hiding your front door key under a rock and a flower bed, connecting to the internet assuming that your system is one that won't be noticed, keeping an encryption algorithm secret, changing the default service port of a network service, writing your password on a sticky note and placing it under your keyboard or mousepad. True security through obscurity relies on using obscure and non-standard technologies. Least privilege and simplicity. The principle of least privilege is for users should have the minimum level of access to resources needed to complete assigned tasks and should be applied to all users. Separation of duties. Extension of principle of least privilege that addresses administrative users. Simplicity is keeping the thing simple is an important part of security. The more complex the solution, the more room for mistakes, bugs, flaws, and oversights by security administrators. Simplicity makes complex systems easier to understand, manage, and troubleshoot. Defense in depth. We talk about this as peeling the layers of the onion back. And so you can see the multiple layers. Multiple security safeguards are needed to provide complete and exhaustive coverage. Multiple layers or barriers to access secure resources. Here's a logical network diagram for defense in depth. The N-tier deployment is an example of defense in depth, deploying multiple subnets in series to separate private resources from public resources. N represents the number of subnets under private control. An example would be we have the internet coming in, we have our firewall, and we have our the switch that has a web server, email server, and then connects to another interface on the inside firewall. And then we'd have a subnet just for the DMZ. Then we'd have a subnet for the data center, as we see the database server there off the switch. That would have its own subnet. And then inside the network, we'd have another firewall, and you see the private VLAN, and that would be another subnet. So that's an example of multiple subnets and how to protect them. Diversity of defense. It supports multiple layers like defense in depth. The difference is that most layers use a different security mechanism, uses a collection of diverse security solutions. Multiple firewalls in series is defense in depth, not defense in diversity. Adding tools such as an intrusion detection system, antivirus software, strong authentication, VPN support, and granular access control is a multi-layered defense type of security. What is a choke point? It forces traffic, communications, and activities through a single pathway or channel. The pathway can be used to control bandwidth consumption, filter content, provide authentication services, or enforce authorization. It ensures that security device at the control location controls everything, also known as a checkpoint, filter pathway, or bottleneck. Weakest link. The security infrastructure is only as strong as the weakest component. Identify the weakest link, then replace it or remove it. Implement an ongoing improvement process and examine technical vulnerabilities and gaps in the security training. Fail-safe. Fail-safe is a series of options where a device can either fail safe, fail secure, meaning allowing some traffic, fail open, allowing all traffic, or fail closed, denying all traffic. Design elements of firewalls and other security controls. Security stance intended to drive security into an organization. Security failure should fail into a state that supports or maintains essential security protections, like the options we just talked about. Maintain a confidentiality and integrity protections. And most fail-safe solutions sacrifice availability protection to retain confidentiality and integrity. In this diagram, we see the concept of a fail-safe security stance. We have a lobby, and our office area is behind a locked door. Forced universal participation. Examples of purposefully avoiding or violating security. Choosing poor passwords, sharing accounts with others, using unauthorized personal computer equipment on the company local area network, or commonly referred to as BYOD, bring your own device, installing an unauthorized wireless access point, using an unauthorized removable media or equipment, using proxy tools to bypass firewall filtering, configuring a dial-out modem connection to establish unfiltered access, and using internet-based remote access control tools to access workstations from an external system without authorization, and installing unapproved software. And your acceptable use policy should state clearly that these things are not allowed. What is AAA? It's authentication, authorization, and accounting. When we talk about authentication, it verifies an identity, takes place at the firewall or beyond. Could be a IAM database of usernames. Authorization occurs after the authentication and determines what you can do on the network. And accounting is how we track who did what to which asset via log files. A firewall handing off authentication tasks via 802.1x to a dedicated authentication server. In this case, we see the internet, and we have our firewall, and a user is going to hit the authentication server first and authenticate before it is allowed to come into the private VLAN. Placement of network hardware firewalls is understand the structure of your network. What are natural or organizational divisions? Do these correspond to subnets or geographical physical locations, like a border, a data center, or another resource that you're trying to protect? Know the traffic patterns of your network. What are common vectors and pathways of communication? And protect internet access points. Firewall protect all internet access points or gateways. Protect remote access and wireless connections. Position a firewall between each remote access server, RAS, or a network access server and the private local area network. Determine hacker pathways. Which access pathways would an internal or external hacker most likely use to breach your network? Assess the entire environment. Does any other unique aspect or feature of your IT infrastructure warrant consideration for firewall protection? Benefits and purpose of a reverse proxy. A firewall service that allows external users access to internally hosted web sources. The benefits are enhanced security. There's no direct access to internal web servers from the public network. Encryption. The proxy server can function as an encryption endpoint, allowing for packet inspection of traffic destined for the web server. Reverse caching. Increased performance because web pages are cached on the proxy server. In this diagram, we see an example of a reverse proxy. We have a client on the business network trying to talk to a web server. In the middle, we have a proxy server that's accepting that HTTP request, authenticates it, forwards it to the web server. The web server responds to the proxy server, and the proxy server passes that request back on to the client. Benefits and purpose of port forwarding. A firewall, proxy, and routing service that can receive a resource request on an interface at one point, then forward the request to another address on the same or different port. a variation or enhancement of network address translation, sometimes called port address translation, PAT. Limitations: does not support caching, encryption, endpoint, or load balancing. Only a single internal machine can use a forwarded port at a time. Port forwarding service are found on almost any service or device that supports NAT. Firewalls, such as hardware and software, wireless access points, and internet connection devices. Considerations for selecting a Bastion host operating system. A system designed, built, and deployed specifically to serve as a frontline defense for a network. The first, or nearly so, host accessed by external entities on their way to access DMZs, extranets, or private network resources. Withstands the brunt of any attack attempt to provide protection for host behind it. Categories of Bastion hosts is proprietary operating systems built specifically to be a Bastion host. Most appliance firewalls use a proprietary operating system. General purpose operating systems like Windows, Linux, Mac OS, Unix, and others can be configured to serve as a Bastion host models. Most are hardened and locked down. And this would be like a pfSense that you build. Monitoring and logging. Watching and recording events and traffic that take place across a firewall. Why log? Why should we log? We validate the firewall rules are configured properly. Historically tracking and trend analysis. Reactive tracking and tracing of attacks. What should be logged? All connection rejections, so all denies. All traffic to successfully traverse through the firewall. Firewall configuration changes. Access to firewall system, and monitoring allows for alerting. Alerting allows for prompt response. Here's an example of a pfSense firewall logging display, interface, and logging. In this screenshot, we can see the time, the date stamp, the process that was being checked at that point in time, the process ID, and the message. And we follow along. The syncing of the firewall, local user database successfully edited user admin. So somebody's logged in and successfully edited the user admin. Then we have the successful login from user admin from the IP address of 172.21.0.1, which is a local database server. And then we go down, we see that a VPN connection. Open VPN tunnel endpoints may have changed its IP, reloading endpoints. And we see the gateway, none available, INET 6 or IPv6, use of the first one configured, reloading filter. So those are messages that we would want to be looking at and determining what's going on the firewall. Understanding and interpreting firewall logs and alerts. An alert is automated notification when a specific event affects the firewall. Common events that warrant alerts. A firewall reboot. Why did the firewall reboot? Connection attempts with the firewall host. Communication to or from a pre-identified IP address or subnet. Detection of some or all attack attempts. Detection of any successful intrusion or security breach. We also try to identify and discard all packets involved in benign sessions between valid host and valid ports. Identify and discard all valid UDP transmissions to and from valid host and ports. Identify and discard all valid ICMP and other authorized protocols to and from valid host. Identify any communication from known malicious addresses. Identify any communication from unauthorized or unassigned internal addresses, and identify any communication to an unknown or unauthorized port on an internal host. We'd also want to identify any patterns or serial communication attempts across a sequential or randomized set of addresses and or ports, and that'd be a port scanner. checking for open ports, and it goes sequentially down your IP address schema: 172.21.01.02.03, and so forth, and trying to probe ports that are, see if they're open. Identify significant volumes of non-session traffic of the same or similar construction. 2, or a small group of internal addresses. Identify any packet of invalid size or invalid header construction. Identify any packet with configured source routing, and identify packets destined to non-resource sharing systems such as firewalls or routers. This is an example of a Windows Defender firewall pop-up alert that you might get if you're using Windows Defender as a firewall. IDS and IPS systems. They monitor internal host or networks, watching for symptoms of compromise or intrusion. An IDS detects when an attack is occurring within the network, and it's a companion to a firewall and reacts to a threat. And it's basically alerting. That's all it does, alerts. Intrusion protection system detects attempts to attack or intrusions before they are successful, often used as an initial layer of proactive defense. And they are reactive and can change rules and be proactive on your security, where an IDS just alerts. It's kind of like the old commercial when the bank's getting robbed and the security guard says, hey, just letting you know your bank's getting robbed. That's all an IDS would do. Here's some more about intrusion detection systems and intrusion prevention systems. They can be signature based. They can have predefined signatures, database that are looking for certain signatures, database detection, knowledge-based detection, anomaly-based detection, meaning your network's not behaving like it should. There's some anomalies, and it'll alert you. And then behavior-based detection, meaning the device get a baseline, and you're outside of that baseline, and you'll get an alert. A SIEM, or Security Event and Information Management System, has 3 processes. So you point all these disparate logs from many devices across your network toward the SIEM. And what the SIEM will do is one of these 3 processes, or all 3 of these processes, look at deduplication. It'll eliminate or silence duplicate events from multiple devices, narrowing down what you need to look at. It's an aggregation point for collecting log information from many systems across the network. And it's a correlation service. It identifies how events captured in logs are related using statistical measures. It also looks at time synchronization, manage disparities between system clocks on the many devices. In-band management, most common method requires using common protocols to collect information about the network. Out-of-band management, when a device, commonly a server, has access to specific devices controlled through a management port in each. You need to evaluate needs and solutions when you're considering designing security. What's business essential? What's business wanted? What's personal? And what's malicious? So you need to think about these in your business, what your business is doing, and how to fit security into those areas. What happens when security gets in the way of doing business? And this is a common problem. You're trying to do the right thing. You're trying to secure the network, and you put too many controls and too many blocks in the way. Users will complain. Users will abandon services where they can. So we can see in the short term, most businesses will disable the security feature so that business can go forward, or they do not perform tasks that security is blocking. Long-term solution is reevaluate the business task in light of security infrastructure, design a new security solution, and modify how tasks are accomplished, and get user adoption. In summary, we've looked at firewall deployment security strategies. We've looked at AAA and what it does. We've explored reverse proxy and port forwarding solutions, why, or the importance of monitoring and logging, and what those firewall logs and alerts mean.